Okay, people, we are going to estimate some quantities today. So you should be in your note packets under the title Estimating Quantities. We're going to try to use powers of 10 to do this. Notice that word estimating means we're not going to be exact. So we're going to try to do a lot of this without a calculator, without the use of a calculator. You can do that when you estimate. All right, so let's take a look at the first one. They give you the population of New York City in 1723 is approximately, or was, 7,248 people. All right, so if we think about that in powers of 10, we could do what we were doing the other day, and we could say, what's the smallest power of 10 that would be bigger than 7,248? All right, so I would want 10,000. That's the number I would want. So if we were going to use the same idea we did the other day, that would be 10 raised to the fourth power. All right, and if we did the same thing with the population 1870, we would want the number 1 million. That would be, again, the smallest power of 10 that was bigger than that population. So that would be 10 to the 6. All right. So what I want you to look at on the note packet is I underlined how many times greater. Well, whenever you want to see if how many times something greater is of the other, well, you want to do the opposite and divide those two numbers. That tells you how many times greater one is of the other. All right. So I'm going to take the bigger number, which is 10 to the 6th, and I'm going to divide by the smaller number, which is 10 to the 4th. Okay. And again, remember back a while ago we said when you have the same base, which is what we have here, 10 and 10, and you're going to divide those two numbers, you're simply going to keep that same base and subtract those two exponents. So my answer is going to be 10 to the 2nd. So I get an answer of 100. 10 times 10 is 100. So my answer for number 1 would be that if I compare these two populations, in 1870, New York City had a population that was 100 times greater than in 1723. All right, now that is an approximation. Let's do something a little different, though, and let's do part B of this problem. It says, now let's make our approximation even more accurate. Now we're going to do kind of like the same thing, but make it a little more precise. All right. If I take 7,248 and I change it to 10 to the 4th, that's really not too close. I've changed it to 10,000. Well, a closer number would be, what if I changed this to approximate it to be 7,000? All right. And let's again use a power of 10. Now this is a big jump right here, so pay attention. This is a big jump. What if I use a power of 10? What if I use 10 to the 3rd? All right, I see I've got 3 zeros there. 10 to the 3rd would be 1,000. Okay, and you may say, oh, wait a minute, that's not really closer to 7,248, but I'm going to put a number in front. Okay, I'm going to put a number in front. If I multiply that 1,000 by 7, and I just do this, 7 times 10 to the 3rd, that would be 7 times 1,000, all right, which is 7,000, which is much closer to 7,248 than this one up here. Okay, so this is again an approximation, but it's much, much closer. All right, so I'm going to use this number, and I'm going to do the same thing with the population in 1870. I'm going to say, you know what? If I could make that into what's really close to 942,292, what's even closer than a million? If I approximated that as 900,000, that'd be even closer. So I'm going to use the same idea. I'm going to go 10 to the, let's see, if I wanted 100,000, there'd be 1, 2, 3, 4, 5 zeros. Okay, that would, this 10 to the 5th would be 100,000. And if I multiply that by 9, that gives me 900,000. This is much closer of an approximation than the 1 million. Okay, So if I use those to divide, I'll take 9 times 10 to the 5th and divide by 7 times 10 to the 3rd. Okay, I can do the same thing. Now, 9 divided by 7, well, that's not going to come out very even, but I can, again, we're approximating, so I can just go 9 divided by 7. That's 1 point, I'm going to say 1.3. All right, I'm going to round that to 1.3. So that's 1.3 times 10 to the, and when I have the same base, 10 to the 5th divided by 10 to the 3rd, I get 10 to the 2nd. All right, now later on we're going to even take this even further and change this number to 130. And we're going to talk about that starting in the next video. Okay, but this is a much closer approximation than I did up there. Okay, it's more like 130 times the population did grow. Okay, so that's a big jump for us. All right, let's try another one. Let's get rid of this one and put in the next one here. I already put down the numbers here. Number 2 says how many times greater. Again, underline that, how many times greater. All right, that tells me we're going to be dividing two numbers. Is the population in New York State than in New York City? All right, so I'm going to do the same thing as I did before. I'm going to try to approximate these really, really close. So I think really, really close to this number would be 20 million. All right, and really, really close to that number, if I rounded it off, is basically what I'm doing, would be 8 million. So I'm going to use those two numbers, and I'm going to try to do the same thing I did in number 1, but I'm going to do it like in part B. All right. So what power of 10 is going to give me 1, 2, 3, 4, 5, 6, 7 zeros? Well, that's simply 10 to the 7th. All right, that would give me 10,000. And if I multiply it by 2, that's 20,000. Okay, I'm going to do the same thing over here. Count the number of zeros. 1, 2, 3, 4, 5, 6. Well, that's 10 to the 6th. That'd give me 1 million. All right, and that I need to multiply by 8. And I think over here I said 10,000. Actually, I meant 10 million. All right, so instead of taking a power of 10 that exceeds this number, hopefully I'm going to use something even closer for number 2 to approximate this. So let's see. I want to know how many times bigger this one, this is New York State, is of this one. So I'm going to take 2 to the 7th, or sorry, 2 times 10 to the 7th, divided by 8 times 10 to the 7th. And again, I've got to take 2 divided by 8. Let's take my handy-dandy calculator and do that. Hopefully we can do that, but we'll check it anyways. Okay, that's 0.25. 0.25. And then I've got to take 10 to the 7th divided by, oops, I wrote that one down wrong. Let's erase that one. That should be 10 to the 6th. All right, 10 to the 6th. So 10 to the 7th divided by 10 to the 6th. All I do is subtract those two exponents, and I get 10 to the 1st. All right, and so again, later on, starting in the next few videos, we're going to change this into a regular number. It actually comes out to be 2.5 if I multiply it out. Okay, and again, I can take my calculator, multiply these two numbers, and that's what I could get. All right, so hopefully you got it so far. Let's go on to number 3 here. You see I put down 9 billion devices. This blew me away. This is actual information. There are about 9 billion devices connected to the internet. All right, now if you write that out as a regular old number, all right, that's 9 million. We got to keep going. You got to go 9 billion. That's like tablets, internet, smartphones, computers, anything connected to the internet. Worldwide, there are about 9 billion devices. Okay, as of 2013. So that's pretty amazing. So they say if a wireless router can support 300 devices, how many wireless routers are necessary to connect all of these 9 billion wirelessly? All right, so we're going to do the same thing. We're going to change these numbers. Oops, I want 3,000. I want 300. Okay, we're going to change these numbers into using powers of 10, and that'll be able to divide them much easily. Okay, or much easier. All right, so let's change 9 billion. I would need a power of 10 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros in it, so that's 10 to the ninth. And if I multiply it by 9, that would give me exactly 9 billion. All right, and do the same thing here. 300, I'd need a power of 10 with 2 zeros, and I want to multiply it by 3, and that would give me exactly 300. So again, we want to know how many of these would it require to support these. So again, if I divide, I got this many devices and this many routers. All right, 9 divided by 3 gives me a 3. 10 to the ninth divided by 10 to the second gives me a 10 to the 7th. All right, so I need this many routers. Okay, and let's see what that number is. Let's take 3 times 10 raised to the 7th power. All right, how many zeros? 1, 2, 3, 4, 5, 6, 7. All right, so I would have 7 zeros. 1, 2, 3, 4, 5, 6, 7. I would have 7 zeros. Put in my commas. That's many. That's the amount of routers I would need to support all those devices worldwide. All right, so that's pretty wild stuff right there. We take a lot of that for granted sometimes when we get on our phones or get on our internet. All right, so let's go back here. Let's clear this one out. One more to go, and that's it for today. So let me clear that off, and let's try number 4. The average American household spends about $40,000 each year. All right, and if there are about 1 times 10 to the 8th households, what is the total amount of money spent by American households in 1 year? Okay, now the first 3 examples we divided, all right, because we want to know how many times greater one number was to the other. All right, now this one's different. We want to know if every one of these are the number of households right here. Okay, is the number of households, and every one of these spends on average this amount of money each year. So we're not going to divide this time, we're going to multiply. All right, so let's put these into scientific notation. All right, I shouldn't even say that. Let's put it into powers of 10. Scientific notation's coming next. All right, so let's put these into powers of 10. So I have 1, 2, 3, 4 zeros. So that's 10 to the 4th. That would be 1,000 or 10,000, and I need to multiply by 4. Okay, so I want to take that amount of money, and I want to multiply it. I'm going to write it like this. I'm going to use my parentheses. I want to multiply it by that number of households. Okay. Now you could write it like this too. You could write it up and down or vertical. This might be the way some of you guys are more used to it. We'll put a little dot there for multiplication. Okay. And we would say, okay, 4 times 1 is 4. And I remember last week, or a couple videos ago, we were talking about how do you multiply with the same base. So if you have the same base and different exponents, when you multiply, you simply add the exponents. Okay. So again, if I pop my calculator up here, let's move it over here, and if I say 4 times 10 raised to the 12th power. Wow, how many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros I need on that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that is the amount of money, approximately, that Americans spend each year. What would that be? This is thousands, right? This is going to be millions, billions. That's trillion. That's like $4 trillion, all right, that we spend on average each year. So there you go. This was a big jump. This video was a big jump in using powers of 10. So if you have the time, please go back and look at some of the examples again, and be ready to go tomorrow.